Thank you for watching Hack the File. I'm Michael Lopez, and on today's episode, we're going to be looking at the Python Networking 101 series. Thank you. All right, we're back, and we're going to dive into the Python Networking 101 book. I started the series. I think I want to do it on the side and get through it. It's not too big of a book, but I'm really interested in it and want to continue to learn about it. So here we go. Python Networking 101 by Windsor Audit. I think it's Windsor Audit. I don't know. Anyways, so let's go ahead and get started. Chapter 2: TCP, UDP, and socket programming. In this chapter, we will delve deeper into the network protocols and layers, exploring their concept and learning how to implement them using Python's socket programming. We will discuss some essential network protocols in detail, understand the layers at which they operate, and practice writing simple Python scripts to work with these protocols. This chapter and various topics covered in it will provide a comprehensive understanding of network protocol layers, along with hands-on experience in implementing them using Python socket programming. This knowledge will enable you to develop more complex networking applications and further hone your skills as a network administrator. Let us explore and learn. So this is all done in Windows. And I don't know if I created a Windows environment. I think I did in the last video on my last computer, so I'm gonna have to probably set this up really quick and then mess with it. So I don't think this is on Kali Linux, even though I got my Linux machine running. I think it's on Windows. So let me go in here and set up the directory, I guess a Python directory environment. Now, if you don't know what that is, I would look at video 1 of this series, and I think I went through that and I set one up, but I'm gonna set another one up because I have a different computer now. So let me do that, and then I'll jump right back on. All right, I'm back. I got PyCharm for 30 days. And I think I'm good to go. All right, let's go ahead. All right, transport layer protocols, TCP and UDP. The transport layer, also known as layer 4 in the OSI model, is responsible for providing end-to-end communication services between applications running on different devices within a network. It ensures reliable and efficient data transfer by implementing various error detection, flow control, and congestion control mechanisms. The two primary transport layer protocols are the Transmission Control Protocol, TCP, and the User Datagram Protocol, UDP. In this section, we will discuss both protocols in detail, highlight their key features and similarities and differences. Transmission Control Protocol, TCP. TCP is a connection-oriented, reliable, and full duplex transport layer protocol. It ensures that data is delivered accurately and in the correct order, making it suitable for applications that require high reliability, such as web browsing, file transfer, and email, and like gaming, right? Gaming is probably UDP because it's faster. Key features of TCP. Connection orientated. TCP establishes a connection between the sender and receiver before transmitting data. This connection is maintained throughout the communication process until both parties have finished exchanging data. And that's the that's the three-way handshake, right? Reliable. TCP uses error detection mechanisms such as checksums and sequence numbers to ensure that data is transmitted accurately and in the correct order. If a packet is lost or corrupted during transmission, the recipient can request retransmission. Flow control. TCP manages the rate of data transmission between sender and receiver to prevent overloading the recipient's buffer. This is achieved using a sliding window mechanism, which allows the sender to transmit data only when the receiver has available buffer space. Congestion control. TCP monitors network congestion and adjusts the transmission rate accordingly, preventing packet loss and ensuring efficient use of network resources. This is achieved through mechanisms like slow start, congestion avoidance, fast transmission, and fast recovery. Full duplex. TCP supports simultaneous data transmission in both directions, allowing the sender and receiver to exchange data concurrently. User Datagram Protocol (UDP). UDP is a connectionless, unreliable, and lightweight transport layer protocol. It does not guarantee the delivery, order, or integrity of the data, making it suitable for applications that prioritize speed and simplicity over reliability, such as streaming media, online gaming, and voice over IP (VoIP). So I sometimes when you get on um, Skype or something like that, Teams or something, and then you get like your screen freezes or lags or something like that. That's because it's lost some packets along the way or something. Key features of UDP: connectionless. Unlike TCP, UDP does not establish a connection before transmitting data. Instead, it sends datagrams independently without maintaining a connection between sender and receiver. Unreliable. UDP does not provide error detection, flow control, or congestion control mechanisms. As a result, it cannot guarantee the delivery, order, or integrity of the data. However, this simplicity allows for faster data transmission and a lower overhead. Lightweight. UDP has a smaller head size compared to TCP, resulting in less overhead and faster processing. This makes it an ideal choice for applications that require minimal latency. No flow control or congestion control. As UDP does not implement flow control or congestion control mechanisms, it can send data as quickly as the sender generates it. This is beneficial for real-time applications such as video streaming or online gaming, where occasional packet loss is acceptable. You get that lag and stuff. Comparing TCP and UDP. Reliability. TCP is reliable protocol, guarantee data delivery, order integrity. In contrast, UDP is unreliable protocol that does not provide any such guarantees. Connection. TCP is connection oriented, establishing a connection before data transmission. UDP is connectionless, sending data without prior connection establishment. Flow control and congestion control. Now, does that sound like something you can hack? It does. TCP, TCP implementation, flow control, and congestion control mechanisms ensure efficient use of network resources and preventing buffer overflows. UDP does not provide any such features. Speed and overhead. TCP has higher overhead due to its error detection, flow control, congestion control mechanisms, resulting in slower data transmission. UDP has lower overhead, faster transmissions, making it suitable for applications prior to speeds and minimal latency. You said this already 3 times. Use cases. TCP is ideal for applications that require high reliability, such as web browsing, file transfer, email. UDP is suitable for applications that can tolerate occasional packet loss and prioritize speed, such as streaming media, online gaming, VoIP. So, when you're transmitting, let's say you're transmitting email, it has to be the exact email you sent. It has to say the same words and everything. But what if you send an email and all of a sudden like half of your message was gone. That's what UDP would do, sometimes. So you have to have something reliable, more reliable with TCP. But if you're gaming and you lag a little bit, or let's say you're streaming something and you're on Skype and then it lags a little bit, that's okay. But it's faster, right? In summary, both TCP and UDP serves different purposes and are suitable for different types of applications. TCP is the go-to protocol when reliable data integrity and order are crucial, while UDP is preferred for applications that prioritize speed and low latency. It is essential for the network administrator to understand these differences of these two transport layer protocols and make the information decision when configuring and troubleshooting networks. Did I already read that on the last video? I hope not. Socket programming in Python. Sockets are the fundamental building blocks of network communication and play a crucial role in establishing connections between devices. They provide an interface for applications to send and receive data over networks. Understanding the basics and types of sockets is essential before diving into socket programming with Python. Basic sockets. A socket is an endpoint in a network communication process that enables data exchange between two devices. Hold on. It is associated with a unique combination of an IP address and a port number, which together identify a specific process running on a device. Sockets enable applications to send and receive data using transport layer protocols like TCP and UDP. There are two primary operations performed by sockets: listening and connecting. A server socket listens for incoming connections from a client socket, while client sockets initiate connections to server sockets. Once a connection is established, data can be transmitted bidirectionally between the server and the client. Sockets can be broadly classified into two categories based on the transport layer protocol they use: stream sockets and datagram sockets. Stream sockets, or TCP sockets. Stream sockets use the transmission control protocol TCP for communication. They are connection orientated, meaning that a connection is established between the sender and receiver before data transmission. Stream sockets ensure reliable, in order, and error-free communications, making them suitable for applications that require high reliability, such as web browsing, file transfer, and email. Do you see the pattern here? Some key characteristics of stream sockets are reliable. They guarantee accurate and order error-free. Yes, connection orientation. A connection must be established before data can be exchanged. Full duplex. They allow simultaneous data transfer in both directions. Suitable for applications requiring higher reliability, blah, blah. Datagram sockets, UDP sockets. Datagram sockets use the user datagram protocol for communications that are connectionless, meaning the data is transmitted independently without established connection between the sender and receiver. Datagram sockets are suitable for applications, prioritize speed. Okay, same thing, right? Some key characteristics of datagram sockets are unreliable. Same thing, same thing. It's the same thing. Understanding the basics and types of sockets is essential for successful socket programming in Python. Stream socket, TCP, and datagram sockets, UDP, cater to different types. Yes, yes, yes. By choosing the appropriate socket, you can develop efficient network applications to meet the specific needs of various use cases. Yeah, it basically said the same damn thing. Could have just put both of those pages into one, saying, TCP and then socket. The TCP socket would be the same thing. Python socket library. Python provides a built-in library called socket that makes it easy to perform networking programming tasks, such as creating, connecting, and managing sockets. The socket library provides various functions and classes for working with both TCP stream and UDP sockets. In this section, we will learn about the socket library and socket, and how to use it for socket programming in Python. Man, that's a lot of sockets. Importing socket library. To start using the socket library, you need to import it at the beginning of the Python script. Okay, so we're going to import the socket library. Like I said, I've got a 30-day trial of PyCharm. I think it's PyCharm. Yeah, PyCharm, which is my favorite IDE. If you don't know what IDE is, Google it. You know my famous words. And we're going to erase all this. I've already created the environment. As you can see, I'm in my environment. So we're going to import the socket. Import socket. Right. All right, let's see what else it's going to want us to do. Oh. No burrs. The import socket. Creating a socket in Python. To create a socket in Python, you can use the socket.socket library function provided by the socket library. This function takes two arguments: the address family AF and the socket type sock. The address family is used to specify the protocol family, IP4 or IP6. And the socket type is used to specify the transport layer protocol, TCP or UDP. For example, to create a TCP socket using IP4, which is what we're going to do, you could call the socket.socket function like this. And here's your object, or here's your whole object, but here's your variable. So TCP socket equals socket.socket, right? There's your, and then here's the socket.afnet. What is afnet? Socket.sockstream. Sockstream, I'm sure, is the TCP. So this has to be IP4. Similarly, to create a UDP socket using IP4, you would use the following code: UDP equals socket.socket, socket.afnet, socket. Yep, it's gonna be a lot of socket. Socket.socket dgram. So these are the TCPs, and here's your IP. So AF init apparently is IP4. Let's put both of these in here, right? So we're gonna move this over and we're gonna copy. And the reason why I'm typing all this is because I need to get familiar with all this stuff. I don't think this came out okay, right? Supposed to have a color. Right here. Oh. There you go. Import socket. Okay, now we're going to put both of them up here because I can create two objects. It doesn't matter, I'm sure. So TCP socket is what we're going to call it. And then look, it gives you the, and that's dope. That's just dopeness. See, that's why I like PyCharm. It gives you, you know, bolt. Well, it gives you your, because I named it TCP, I guess. So then it gave me my TCP on IP4. That's awesome. Let me see if I do. Well, maybe you have to name it that. I don't know. But I'm gonna put a little. I've never done this before, so we're gonna put a little note that says TCP socket. I mean, you know, I guess. Right? We're actually creating two different ones. So now we're going to do UDP. Look at that. Nice. See, that's why I like PyCharm. PyCharm is dope. Look, and then it gives me some more stuff I could do. Man, it actually had a, yeah, to bind the socket. That is cool as crap. Alright, we're gonna save this actually. So I'm gonna go here, save as. We're gonna call it, yeah, we can call it, Python socket.py. Is it in my environment? It is. Okay. Let's see what else we got. Porting socket library. We already did that. Okay. Binding socket to IP address and port. Before a server socket can listen for incoming connections, it must be bound to an IP address and port number. This can be done by using the bind method of a socket object. The bind method takes a single argument, a tuple containing the IP address and port number. For example, to bind a socket to the IP address of 127, this. If you don't know what this IP address is, Google it, type those words in and see what it says, and say what IP address is this, and port number 12345. You would use the following code. So I like books that explain stuff and do that, but the thing is, this one's fine, right? But why doesn't it try to I don't know, give you a different port? This is 12345. Really, it's just a basic port they're gonna use, or a port they're gonna use. Are you really gonna use that port? I don't know. So, but we're gonna just write this in here, and then we're gonna modify all this as we go. So this one actually had the bind. Address equals, and then we'll 127 dot. So this is basically your home IP address. Yeah, see, so TP at socket bind address. Look at that. See, it just gives it to you real nice. And I'm gonna put notes here, right? Because we're learning. So I'm gonna say this binds the socket to the home, to the, I'm just gonna put IP address and port number. Like that. And I can't spell. Yeah, okay. Looks good. I'm gonna save this. Save all. Alright. Import socket. Alright, so we're rocking and rolling already. We're setting up a basic little socket already. Let's see. Alright, closing a socket. When you're done using a socket, it is important to close it using the close method. This frees up system resources and prevents potential conflicts with other applications. TCP socket close. Alright, let's do that. And then will note this closes the socket. If you don't know what I'm doing here, if you put your little hashtag there, your little pound symbol, you can put a note and it doesn't read that. It's just notes. It'll just read these things, right? So, all right, here we go. Let's close this socket. I'm gonna go TCP socket, and if I just press, see how it selected that? If I just press tab, it'll. Oh, maybe not. TCP socket close. So that's not the one I wanted. So socket dot close. Now it'll let me pick it, and I just press enter, and then you can actually like go through them. Dot, and then you can go bind, listen. You can pick whatever one you want. And we want close, right? So I'm gonna pick that one, press return. Close my socket. All right. Now that you have a basic understanding of the socket library and how to create, bind, and close sockets in Python, you're ready to explore more advanced topics such as establishing connections, sending and receiving data, and implementing server and client applications using TCP and UDP sockets. All right, TCP socket programming. Now let us learn and practice to establish TCP connections, send and receive data over TCP, and terminate a TCP connection using Python socket library. Establishing a TCP connection. To establish a TCP connection, the server must first create a socket, bind it to an IP address and port, and then start listening for incoming client connections. The following step demonstrates how to achieve this. We already did that. Import socket, server socket equals socket, blah blah. Did I do that? Socket string, server socket. That's what we set up, right? Bind it. I don't know why it's doing this twice. I mean, it showed us the example and taught us, and then it did. Now it's doing it exactly the same. That's not. That's just redundant. Could have just said. We could have skipped that whole thing and said, now we're gonna set up. You could just went to this, but it's okay. Everybody learns differently. Socket server listening 5. This argument 5 is the maximum number of queued connections. All right, so let's start doing this. If you guys want to follow along, pause the screen, start typing this in for yourself, read it yourself, whatever. But I want to move it off the screen now, so I can copy it, so I can follow along. All right, so we're gonna create the socket. So import socket, TCP. Okay, so now we're gonna go here. And I'm going to say server. Now we're going to create the server socket. Server socket equals socket and IP4 TCP, right? And we're going to say okay. And we'll do let's bind the socket. So I guess I can take this one, cut, paste. And that's fine. That's because I don't have this up here. But we're going to address is the same. And the server socket bind. Bind address. So we're just modifying all this stuff that we used already. Listen for incoming connections. Server socket listen. Can't spell for shit. All right. Listen for incoming connections. So socket. Nope. Server socket dot listen 5. Okay. Now we're going to accept incoming connections. Client. I'm sure it's that one. Client socket. Client address. Client address equals server socket dot accept. Okay. I'm gonna go print f okay. This Prince connection was established. Alright. And we're going to leave this here because we're probably going to use it here in a second.
Live long and prosper.
Alright, here we are. On the client side, you need to create a socket and connection to the server's IP address and port on the client side. So this was the server side, right? Create a socket. Oh man, that's the last one. What the hell? Nope. Just doing it over and over again. Okay, that's why I got confused. Alright, create a socket. So we're gonna do this, creating a socket. It's just kind of redundant. I mean, it should have just did this once. Create a socket, import socket. We already have the import socket up there. That's just confusing. Client socket. Is this on a different? Fuck, I have no clue. Import socket. create client socket. I already do that. All right. So let's I like to do this type of stuff. Just I don't know if anybody else does, but I like to separate my code just like that. I don't know if that's gonna mess it up, but um, import. Oh man, just take this client. Oh crap! Press the wrong thing. Client socket equals so it's basically this one. All right, let me see. Yeah, that looks right. Connect to server. All right. Oh, that's wrong. I'm looking at the wrong dang one.
Live long and prosper.
And I'm sure we're not going to do UDP yet, so I'm going to delete that because it's going to confuse me. I'm going to save all. So we set up the server. This is a server thing, I could even. Anyways, then I separated it, and now I'm going to set up the server. I mean, I'm just thinking to myself why I put this here to separate it, which is fine. It's my code. All right. Now, sending and receiving data over TCP. Once a connection is established, you can use the send and receive methods to transmit and receive data over TCP. So we've got 2 more minutes, and then I'm going to make this video. And we might just go through this whole chapter. It's really fun. So this video might be an hour long, but got like 2 minutes before it stops, so I'm gonna go ahead and restart it. All right, sending and receiving data over TCP. Once a connection is established, you can use the send and receive methods to transmit and receive data over TCP. Sending data. To send data, you can use the send method of a socket object. This method takes a single argument, the data to be sent, which must be a bytes like object. Example, client side. Data equals hello server. Client socket send data encode, converts the string to bytes and sends it, right? Receiving data. To receive data, you can use the receive method. So this is the send client send socket method of the socket object. This method takes a single argument, the maximum amount of data in bytes to receive, and returns the received data as bytes like object. Example, server side data receive, data equals server socket receive in bytes, receive up to 1024 bytes of data. Print f receive data decode, convert the bytes to a string and print it. Oh, that's cool. Let's do that. We set that up because it's gonna have us just do it right here. But let's set it up anyways. It's okay. It didn't really bother. I mean, it bothered me, but it didn't really matter. So let's go ahead and just follow this instructions. Okay, so we have that closing, and we're gonna do this and separate all this real quick because I'm sure I don't have to rewrite that. I'm gonna separate that, right? All right. Now let's send and receive. So let's set this up. This. Yeah, that's what that does. So then we'll just there you go. We'll separate that. And we'll receive. I before E except after C. Data equals server. Yeah. works. Now you guys don't have to put these little things, but I do. Let me see what sections of this code is separated. And you can even put titles on them and stuff if you want to get, in parentheses. I mean, in anything. But I think that's, for me, it allows me to see what sections these are, because this is a server socket, and here's everything related to it. This is related to that. This is related to this. They all do separate things, so within themselves. So it kind of helps me look at the code when I separate it like that. You can write your code however you want to write it. I write it like that so I can see. Let me see. This is just a practice code, anyways. Okay, we're gonna make sure that we print this. Print F received. There you go. Data decode. Perfect. And did I put that explanation on that? Yeah.
Live long and prosper.
You too, Spock. This prints that the data was received. Man, I can't spell for Nikes. I before E except after C. Okay. And we're gonna go and save that. Save all. Okay. Does that look good? Yeah, received. Alright, now we're gonna close the socket. Alright. And we're gonna take this, cut this. This closes the socket. This closes the server side socket. This closes. I mean, I don't know why it does that twice. That's weird. This is going to have us all change all that here in a minute. Watch. This is where we're at. Okay, now we're on the send and receiving. This is where we're at. In the simplest terms, to execute TCP socket programming in Python, you will first need to build and bind a socket then establish a connection, then send and receive data, and lastly close the connection. So this is the simplest one. Implementing a TCP server and client. Consider so far what we've learned. We can start by creating a simple TCP server and client using Python socket library. The server will listen for incoming client connections, receive a message from the client, print the received message, and send a response back to the client. TCP server. Create a file named tcpserver.py and add the following code. So it's everything that we just did, and then now it's doing a while loop. Okay, so this is what we're going to do. We're going to take this and we're going to rename it after I. Or I could take this and save this actually as a template. I can call it template. Well, we don't need to do that. That's exaggerating. Okay, so let's just upgrade this and we'll save it as what did it want to be saved as? TCP server dot py. All right. And then we'll close this one, open this one. All right. Import socket. What happened? All right. Import socket. Create a socket. Socket server. Socket stream. Socket server. Socket stream. Find the socket. Yep, same thing. Server socket address. This is just stupid. Listening for incoming connections. Listening for incoming MACs. Yep, same thing. Server listening on address. Listening for incoming connections. Listen. Hold on. Server socket listen. Server socket bind. Let's do this. I don't think I separated this. And then we'll print that works for me. Server now listening. All right. We could go to the next thing. Now we could take this and delete it. So it doesn't want us to have that. Okay. Now we're going to do a while statement. how it works. F got connection from. That's not gonna work. Shit. Alright, there you go. Okay, receive data from the client. And I'm just putting the right there. Receive data. Bitch. Sorry. Okay, then we'll receive. So now we receive the data, then we print that we received it. Receive the data. Okay. Oh, we gotta decode it. Response. Close. Close the server socket. And we'll take all this and we'll just delete it. All right, let's see what happens. And we need to create a file called no. What? TCP server, right? Okay, now we got to do TCP client. All right, this is the one we just did. All right, we're going to do TCP client. It says create a file named TCP client.py and add the following code. And if you guys want to pause it, you can do it yourselves. We're going to import. It's the same thing. We're going to go through and change the values. Running the TCP client. So I'm just going to go in and change the values. I'm going to copy and paste and change the values. And then, okay, so let's go ahead and do that. So I'm going to say, do a new one. I do a new. How do I do a new one? Do I new? Like that? Oh, what is it called? TCP client. .py. Okay. We're going to copy this. I'm going to paste this. And I don't think I did that right. I said new. I don't think I wanted a new file. I think I wanted a new. Dang it. Oh, let me see. Main Python file. think I'll have to delete that sucker. Alright, deleted that one. Okay, I think I put that one as a new file on my thing. Okay, so now the main TCP client, TCP server. So we're going to do TCP client. We're just going to change all these values because it's going to be the same thing, I'm sure. Create a socket. And this one's going to be client socket instead. So equals socket. Yeah. This address is going to be the same. Okay. This is going to be called server address.
Live long and prosper.
Server address. Client socket. Client socket. Bind. Server address. Okay. So, yeah, client socket. Server address. Client socket. Bind. That's going to be connect. Connect server address. So it's connecting to the server address. Client socket connection server address. Your server address is here. It's creating the socket, client socket. Alright. And we're going to print. So this one doesn't need the listening, I don't think. Yeah, it needs to send, but we're going to print. If this doesn't bind, this one is connects to server this.
Live long and prosper.
This connects to the server. This creates a socket. IPv4/TCP. This creates a client socket. This connects to the server. Server address that prints connected to servers, and then it gives the server address. The one that it needs to talk to, that it wants to communicate to, right? This sends data to the server. Okay. Let me see. Servers. Clients are connected to the server. Print. Print address. Connect to server address. Send data to the server. It sends data to the server. Data. data equals hello server. Hello server. Client socket. Send data encoded. Perfect. Okay. Spelled hello now. This, I should have just rewrote it myself.
Live long and prosper.
You too, Spock. We're almost done. We're just gonna run this one, and then we'll do UDP on another video. This video's getting really long. I mean, I'm having a lot of fun. I would finish the whole chapter, but it's gonna be a really long video. So this. Okay, we just sent the data. Client send. This receives. Doesn't. And we want to put that in there. It doesn't say to put it in there, so. Why is this? Oh, probably because of that. I don't know. Rename response defined above without usage. Client socket receive response. I guess that's fine. I don't know what that. And then we're going to take this out. And I'm going to double check all this because this is kind of, why is that not there? Redeclared response defined above without name. Byte socket receive response byte socket receive. I don't have to do that. Why is it giving me a... That's what it says to put. Running, okay, that's fine. It should work. If it doesn't, we'll fix it. Running the TCP server and client. To run the TCP server and client, follow these steps. Open two terminal windows. In the first terminal, navigate to the directory containing the TCP server py and run the following command: Python TCP server.py. This server will start listening for incoming connections. In the second terminal, navigate directory client py and run the following command: client py. So let's run the TCP server to start listening. And this is thinking that we're doing it off a command line, which you can, but we're running an IDE, so I'm just going to get my server and I'm going to run it. And does this... Yeah. So this should be... This didn't say start listening. Okay, let's see. Let's open the command. Let's debug this guy. Let's see if we can run it in the terminal. What? What's happening here? Mm-hmm. Yeah, that's... Oh, server now listening. Alright. Was that popping up somewhere else when I was running that? Probably. Because that should have worked. I don't know what. Maybe it was popping up a... Anyway, server now listening, so now it's listening. Let's move this up so you guys can see. So I ran it in the command. So I went down the command line, and it opens a PowerShell here for you. It makes it easier. And then I just ran Python TCP server.py. It ran this program or script that we created. Now it's listening. So server now listening because it ran through this one by one. And then boom, got here and said server now listening. And then now it's running through this while loop while true. So if it hears something, then it'll run through here. Okay, so now we'll go here. Open up another terminal. I don't know if you go here and you open up another terminal. Oh, it takes a minute to... Alright, I don't know, it takes a minute or something. I think it wants to download the newest version or something. I don't know what the hell. Okay, now we're gonna run the Python TCP client. So Python TCP client, and let's see if we wrote it right. Line 3, input response. Line 8, server socket. Only one uses of each socket address protocol network. Port is normally permitted. Python. Line 3. So let's look at line 3. Oh man. What the? From TV. That's not good. Line 8. Alright, let's rerun that. Connected to server at blah, blah, blah. Received hello client. Alright, it worked. Received hello client. So what happened is when I first ran it, I had some code in here that I had to delete. You too, Spock. And I forgot to erase it, or I forgot to put this hashtag here. So I tried to read it, gave me an error. Tells you what line. It was line 3. So I looked up here, line 3. Obviously, I found the problem, erased it, saved it, reran it, and it works. So this is the old one, so I reran it, and then it said connected to server at my home address on this port. Received hello client. Let's change the data. Hold on. The server will start listening for incoming connections. That's what it did. In the second terminal, navigate to the directory containing the pi, run the following pi. Yep. The client will connect to the server, send a message, receive a response, and print the received data. It did. Did it? Observe the output in both terminals. The server should display the connection details and received message. Okay. So the server is this one. It said listening, establish connection. Yep. Hello server. Receive the data, hello server. And then it came out of the while loop. And then, so that worked. The server should display the connection details to receive the message. Yes, and hello server from the client, while the client should display the connection details and the received response. So, connection to a server received hello client. That's pretty cool. So they're talking back to each other. That's awesome. Creating a TCP server and client in Python requires established connections, binding sockets, transmitting and receiving data, and finally closing the connections. Additionally, you will need to create sockets and bind them. If you follow these instructions, you will be able to construct a wide variety of server and client applications that take advantage of the connection-oriented reliability characteristics offered by TCP protocol. And the next video we'll do this UDP one, but it's going to be the same thing. It's the same thing. You're gonna use UDP instead. So we might skip this one. It's the same exact thing. We're not gonna learn anything different from setting this one up. It's just different. Sock dgram. You bind it. Uh, I mean, we might run this one real quick through the next video, but I mean, might be a little bit different, so we might have to. Implementing a UDP server and a client. Okay, so this is so we're going to import socket. It's the same thing. Print listening on it while true, receive data. It's the same exact thing. UDP client. It's just less. It's the same exact process. Observe the output of both terminals. The server should display the received message in the client. So this is the same exact. Writing in UDP socket in Python is far less complicated than writing a TCP socket. Okay, so it's just easier because now let's look at why, right? We don't need to. Here's your socket. We bind it the same way. Hello, client. Okay, so it's probably easier because we're missing I don't know. It says it's easier, so yeah, we could just finish up this chapter. I don't think we need to do the UDP one. Due to the fact that there is no need to create a connection between the server and the client. Okay, so we're skipping the connection part. You can construct server and client programs that use the speed of simplicity offered by UDP protocol by employing connectionless sockets to communicate with each other via methods send to and receive from. Summary: understanding network protocols and layers, as well as socket programming in Python. Were the primary focuses of this chapter. We started off by conducting some conceptual research on network protocols and the significance of these protocols in terms of their role in facilitating communications between devices on a network. Following that, we dove deeper into the specifics of transport layer protocols, specifically TCP and UDP, due to the significant impact that they have on networking. Transmission control protocols, also known simply as TCP, is a connection-oriented protocol that ensures the delivery of data in an ordered, reliable fashion. We learned about the process of closing connections, the three-way handshake that is required and established in a connection, the flow control, congestion control mechanisms ensure data integrity in the process of establishing a connection in the first place. User Data Protocol, also known as UDP, is a connectionless and lightweight protocol that offers more rapid data transmission at the expense of reliability. We went over the key differences between TCP and UDP, as well as how each protocol is best suited for a specific kind of applications. Following that, we moved into the Python socket programming, which gives us the ability to create network applications by utilizing the built-in socket library. We began by gaining an understanding of the fundamentals of sockets, which include different types of sockets, TCP, UDP, as well as a procedure for creating, binding, listening for connections through the study of TCP socket programming. We became familiar with the process of establishing connections, sending and receiving data over TCP, and closing TCP connections. For the purpose of demonstrating these concepts, we built a straightforward TCP server and client. Following that, we went on to study how the program uses UDP sockets, which entails working with the connectionless sockets and transmitting and receiving data using UDP. We went over the fundamental steps involved in creating a binding sockets, as well as sending data and send to methods and receive data from method. In order to better illustrate the concepts, we also implemented a straightforward UDP server and client. In a nutshell, this chapter laid a solid groundwork for future studies in Python socket programming and provided an overview of the network protocols and layers. It really did. I really like this book. I mean, it's kind of redundant, but you know what? It's easy to follow. Working with an application, right? It's easy to follow. You know, the thing is that this is not a beginner's book. You have to have had some experience with IDEs, or you have to have a lot of experience with command line. So, what this book wants us to do is it wants us to open up a command line, and it wants us to create these all this Python code in command line or IDE, I guess. I don't know, but it doesn't. It actually says to pick your IDE, right? But it doesn't explain how to use the IDE, right? So if you don't know how to use one, and you would have been hung up on trying to figure out how to open, how to find your directory, where to put it, how to create that environment with your IDE. I don't know how to you know uh, find the command terminal and type in your commands that are in your directory, since I'm in my environment, right, and I'm a projects directory right here. So I mean, there's a lot of stuff that I already knew how to do because I messed with Python and their IDEs for a while, or I've used PyCharm, and I think the free one is MS something, can't remember. Um, I mean, anyways, I've used different ones. There's a couple free ones, and so I've done that for a while. So I know kind of what I'm doing. If you don't know what you're doing at all, this would not be that easy to follow. But with this videos and stuff, you can see what I'm doing, and I can just give you the rundown. So I started my IDE, and in my previous video, I'm sure I did the same thing. I don't know, but you can follow from there. But I just created new um, Pi scripts like that, and then and then I ran them individually. I don't know why this one doesn't work, but so I can run that and finish. It probably just runs. I think that's just for debugging. It probably ran through it and then closed it because I don't know. So but you have to run them in your command lines, and that's it. So yeah, I like this book. It's fun for me because I can follow along. I know what I'm kind of doing, and so you guys need to follow these videos, and it'll be fun for you, and you'll learn too. So all right, that was Hack the File, and I'll see you next time. Hope you learned something. Have fun.